at creating a quadratic equation from a graph. So as of right now, we know three different types of quadratic equations. Okay, first one is our standard. Okay, and it's written as, do you recall, ax squared plus bx plus c? You remember that one? Okay, then we have vertex form. The vertex is ax minus h squared plus k. And I guess I should be writing in, you use function notation, right?
Yeah.
Okay. And then finally we have factored, which is f at x, ax minus r, x minus s. Okay, so these equations here are the three that we're used to using when referring to a quadratic equation. And each of them has their own benefits and pieces of information that's really simple to see. We should look at our graph first. Actually, you know what? I'm going to highlight what's good graphically about each one. The standard form, in terms of graphing, it's a really tough one. It's tough to see right away, but the c value is actually the y-intercept. So that's one key piece of information, okay? So our c value here, that's actually equal to the y-intercept. So just keep that in mind. It's not a huge part of graphing stuff, but it does help. Our vertex form, well, the h and the k are essentially the x and y of the vertex, correct? This h, and depending how you read it, whether it's negative or h, what I'm going to say, it's the opposite. So I'm going to say the h value and the k value, okay? Those are our vertex, so they can help out there. And finally, the factored form, well, the r is an x-intercept, and the s is another x-intercept. In fact, I should have just wrote r, s, and r. That would have been a nicer way to write it. Okay, so those are your x-intercepts. So each of them having their own major benefits, and just be aware that the a value is essentially the same in all of them. Okay, so we have a graph on the next page here, so we'll take a look at it. Now, maybe you don't notice yet, but the goal of this will be figure out the a value. It's actually, because I had to write the equation in, you can technically see where it is. But just imagine that these were the only pieces of information we were given. The first thing we want to do is kind of deduce what is important from what we've been given. Okay. For instance, they've been highlighted. What is this point that they've highlighted? What would you call that?
The x-intercept?
Yeah, exactly. And there are two of them. Okay, so that's an x inter and another x. Oh, let me turn. Okay. Like I said, those were the two x-intercepts. They kind of disappeared there when I paused. Sorry. And finally, what is this piece of information?
The y-intercept?
Yeah. So we have two x-intercepts and we have a y-intercept here. Okay. So we have -2, 0, 7, 0, and 0, 14. So we're going to go back to our other page, and we're going to essentially try to piece that information into one of the three forms of the equations. So we had found, I'm going to write them in their colors. We found our x-intercepts, and they were -2 and +7. Okay, in other words, the coordinates were -2, 0, and 7, 0. And we knew the y-intercept, which is helpful over there in our standard form, which was 0, -14, I believe. That was the actual coordinate. Let me quickly check. Yeah, perfect. Okay, so we've got a lot of information here. Let's take a look above at which of the three forms this will be helpful for building. Okay, we do have a piece of standard form, so maybe let's see if we have enough information to solve for standard form. Do we have any of the information about vertex form? No, so that's probably not going to be what we're going to be using. And factor form, we have x-intercepts, so that might be nice. So let's break it down. We've gone from 3 to, we've deduced it down to 2 in our standard form. So standard form, our function at x is equal to ax squared plus b at x, and our c value is -14, okay, so technically plus c, and we're going to replace it with 14. Okay, in our factored form, we have f at x, our a is unknown, we have x -2, so that actually becomes plus 2, right, because it's technically minus r, and x becomes minus 7 because this is technically minus s. Okay, so when we take a look here, what we really want to look about or look at is how many variables are missing. Okay, now we have our x and our y, okay, because we know we can replace f at x with y. We have both of those missing in each of these, but those can be replaced, okay? Now I want you to think of it this way. In this equation, we have an x-intercept. This represents another x and a y, okay? Either of these, actually. So we can replace all of the x's and this y. So they kind of fall off our unknowns list. We can actually figure them out. Same goes for our factored form. This y could be either the it could be the negative 14, because that's the one piece of information we haven't used. Okay, so I'm going to recap that again. In the standard form, we haven't used any of the x-intercept info, so we can use either of these as the x or the y. In the factored form, we haven't used the y-intercept, so I can use this as the x or the y. So those are essentially covered. Okay, let's think of those as covered. That still leaves us with an A and a B. We have two pieces of missing information, which means in order to find two variables, if you think back to your grade 10 stuff, you need two equations, and we don't have that. So this standard form, we don't quite have enough information to build this standard form, okay? In our factor form, though, remember we had a y value and two x's. That only leaves an a value, which is great because we have our one equation, right? We only have one equation, whether we use the standard or the factored. We can solve for it in factored form, okay? So that was kind of a way to deduce it. And as you look at things, essentially, probably the best two to ever use when looking for an a value are either going to be your vertex or your factored form, depending on whether they give you x-intercepts or a vertex. The y-intercept is not enough information to build a standard form, but I wanted to go through that idea, okay? So now that we have that, this is great. So we can take our other piece of information, this being an x value and a y value, and we're going to plug them in. We're going to plug in our 0 for x in both of those, and we're going to plug in our negative 14 for our y value. So we get negative 14 is equal to a, x becomes 0, okay, so 0 plus 2, 0 minus 7, okay? This is great. Like I said before, only one variable now, so this is very solvable. We just have to isolate for a. So let's go through our bed mass here. I'm going to do the rest in, I guess we'll do it in blue. So we have negative 14 is equal to a. 0 plus 2 is 2. And 0 minus 7 is negative 7. Okay. This multiplication here, we can just multiply our 2 and our negative 7. And usually when we write something with a variable, we put the variable at the end, and these numbers become the coefficients. So we have negative 14a. Okay, and the goal here is to isolate for a. So because this is times 14 on this side, in order to move it, we have to use division, right? So we're going to divide by 14. So our a value, negative 14 divided negative 14, is just the number 1. And if we go back now and we think about it, okay, though I had nothing written in here, for a value, if nothing's there, we assume the number is 1. If you watch this graph, nothing will change when I put it to the value of 1. It stayed the exact same. Where, just to show that it does change, if I made it 2, it's very different. Or if I made it 5, very different from before. Okay? So although I hadn't written it in, that was the goal. Or that's how we can find our value of a.